Okay, so we just looked up, and the way that Python 3 now handles dictionaries, the key value pairs are maintained in the order in which they're entered, but this is not guaranteed to be true, so it's advised that you don't depend on the order that the keys are stored in the dictionary for anything. And if you do need a order to matter, there's an object called an ordered dictionary that you can use. Okay, so just real quick, sets. We've covered this already, but sets are sets of characters that also don't have necessarily any particular order. So we can use this and sign to get the intersection of a set, or this bar to get the union of a set, and we can use this minus sign to get the difference, or things that are in one set but not the other.
Wait, because with the set function, put it in alphabetical order, right? Because when you spit out y and x there, it put them in alphabetical order.
It seems to be, but I believe this. There is no. Yeah, it appears to be putting them in alphabetical order, but they don't have an order. It's just a set. So sets don't have order. It's not like a list. You can't say what's the fifth element of this set. That doesn't mean anything. So you wouldn't you can't index them. You can turn a set into a list, and then it will have order. But a set is just a bag of things so it doesn't have any inherent order. We saw Boolean before, so these have this Boolean type, and so, for example, if we do 1 is greater than 2, that's false, and then there's a few things going on here. One is we're evaluating the statement, which is false, but then when we combine them with a comma, we get a tuple. This is just the way that that Python stores them. So these have a value, either true or false, depending on whether this expression is true or false. If we also have this thing called Bool, which basically converts an object into a true or a false. So if we do it with a number, pretty much any number will evaluate true unless it's 0, and then it will be false. And this has some unexpected implications. So if we try to evaluate, so first of all, these Booleans have special meaning in Python. So we can type you notice how when I type them they show up not just green but bold. They're bold because these words have like here they're functions. This is a function, but here these are actually these words have particular value. So I can say true or false, and what I'm really asking is if this statement is true, this one is false, and the value of that is true. But when I try then to add things together, I get it basically represents false as a 0 and true as a 1. So if I can add something to true or false and get unexpected consequences. So, and here I can say is true equal to or equivalent to 1, and it says it's true. Yes, it is equivalent to 1. But that if I say is true is 1, it will say no, because this is basically saying, do they evaluate as the same thing? And they do. But are they the same object is what this is asking, and it's false. It's the same thing with false. False is equivalent to 0, but false is not the same object as 0. This doesn't come up that often, but it's good to be aware that if you can use this to your advantage in certain cases. None is a similar type of thing. It has this very special meaning. So you type the word, anytime you type the word true or false, if it's not in quotes, it will be interpreted as this having the special meaning. So none is the same way. If we can store none as something, and actually if I just enter it, it doesn't print. Let's see what happens if I type print. Yeah, so it will print the value, but when I just type on a cell in a Jupyter notebook, it doesn't maintain it. If I uncomment this and try to add one, it says that the none type doesn't support addition. But if I have a list of none, it will allow me to duplicate it. So, and if I go up here, so this type of this none is called a none type, and it comes up in certain examples, and NumPy has its own version, which is called nan, or not a number. If you've ever used MATLAB or something, nan, it's basically like an empty placeholder. It can be useful if you want to initialize something as a none type or not a number. So, and this type function is super useful. So sometimes you want to know, like, what this thing is. What is this thing? Like, is it a list? Is it a dictionary? Like, it's just helpful to sort of debug. So we have this thing called type, this function. So we can say type L, and L is a list. So that's what it tells us. If we do something very meta, and we say, what is type L? The type of type is type. So it has its own type. But this can be really useful. So we can go back and say, what is the type of false? That's a bool. Let's we can say, what is the type 1? What is the type 1.0? What is the type? So this is it's really handy just to kind of remind yourself what you're dealing with, and then, because depending on the type, that dictates what you can do. This, that's a list, it's a tuple, right. It's a dict, or a dictionary. So this kind of covers all the types that we've seen, and a very handy function to have to keep track of things. Are there any questions on all that? If not, that's the end of lesson 7.